We have a geometric series that looks like this. Consecutive terms have a common ratio. Let's solve for the last term in terms of the previous two. We also have an arithmetic series that looks like this. Consecutive terms in an arithmetic series have a common difference. Let's solve for the last term in terms of the previous two. Let's start building our series. The first three terms are geometric. A2 through A4 form an arithmetic series. Let's factor, so we might see a pattern more easily in our terms. A3 through A5 form a geometric series again. Canceling out terms, A4 through A6 form an arithmetic series again. We continue on like this, being really careful with our algebra, factoring, and canceling out terms. Here's A7, here's A8, here's A9. We have information about A13, which is odd, so let's see if we can find the pattern in the odd terms. This is what an odd term looks like. In the 13th term, k is equal to 6. The 13th term is 2016. Here's the prime factorization. All of our terms are integers, so we are looking for perfect squares from this factor that evenly divide 2016. Our choices are 1, 4, 16, 9, 36, and 144. Let's try them. When a is 2016, 6r minus 5 is equal to 1. That leaves r equals 1. In the problem statement, we have an increasing sequence of positive integers. So this would all be a sequence of all 2016. With a equals 14, we have 6r minus 5 is 12, and r is 17 over 6. This gives us our second term, which is not an integer. We let a equals 56, so 6r minus 5 is 6, and r is 11 over 6. Again, we get our second term is not an integer, so not valid. If 6r minus 5 is equal to 3, then r is equal to 4/3. Again, our second term is not an integer. Let's try if 6r minus 5 is equal to 4. This gives us r is equal to 3/2. Our second term is an integer. Let's check our third term. Sadly, it isn't an integer, so not valid. Let's hope our last option yields a valid solution. With 6r minus 5 equals 2, we get r is equal to 7 over 6. Our second term is an integer. Our third term is an integer. Since this is our last option, I'm inclined to believe that this is going to lead to our solution. The problem asks for A1, which is 504, and that's our answer.